What we're looking at in this video is how we can count in binary, so when we've just got ones and zeros available and not the other numbers. And before we take a look at how we're going to do binary, we're going to take a look at how we do denary, which is base 10. And so let's go and recap what you probably learned when you were 5 or 6 or maybe earlier. So what we have is a ones column, and this is easy. Initially it's got no balls in it, so that would be 0. And we put one ball in, that would be 1. 2 balls, 3, 4, 5, 6, 7, 8 and 9. So this is easy to represent because we've got numbers and we just have a new number every time we add a ball. But when we get to 9, we run out of numbers. We don't have another number beyond 9. So what we do is we say, if we put just one ball in this box, that will represent 9 plus 1, which we know is 10. We've given it a different name, but in writing we don't have a different way to put it. So we take all of these balls out and we put just 1 in the tens column, and so that number now that we're representing is 1, 0. So we've got 0 in this column and we've got 1 ball in this column, and we call that number 10. And so now we can start adding balls again, and so we add more balls here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this number here would be 9, 0. And if we want to start adding more balls, we could still put more balls in, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this would be 9, 9, or 99. So we've run out again. We try to add a ball to this, we can't. We try to add a ball to this box and we can't. So now we need to use the hundreds column, and so we say if we put just one ball in the hundreds column and then we erase out all the others, we will have 100 or 100. And so the number which we're representing here is 1, 0 and 0, which we know as 100. Now, counting in binary may look confusing. The best thing about it is that it's actually really easy. In fact, it's even easier than counting in base 10 because you've only got 2 numbers to learn and you already know them. So let's look at how we do it with binary. And so what we're doing here is exactly the same, but each of these boxes can only store one ball. They either have a ball or they don't. So initially I have 0. I'm not storing anything. And in fact, all of these boxes contain 0. And this very much looks like binary. So now I put one ball in. And so now this is zeros all the way across. And I've got one ball in, so it's a 1. Now I've run out of room in this box to put any more balls. So what do? Exactly like in base 10. I say I'm going to put a ball into this box and I'm not going to put a ball into this box. And so now I will have 1, 0. Now this isn't 10 because 10 has a completely different meaning. This is a 1, 0. And the number which that represents is 2. So this was my ones column just like it was in base 10. And this one here is therefore my twos column. If I want to represent the number 3, I can take my 2 here, add 1 to it, and so this here I'm representing 3, and that would be 1, 1. So 1, 1 is the same as 3. I run out of space again if I want to add another ball, so I put my next ball in here, and I erase the other 2. And so this here is representing now the number 4. I've got one ball in here and no balls in here, and this represents the number 4. So this is my 4s column. And you see that every time here when I'm thinking up the column numbers, I'm just doubling each time. So that's my 8s column, my 16s, my 32s column, 64s, 128s, and 256. And so on up. So now, if I want to create a number, all I have to do is to put the appropriate balls into the appropriate boxes. So let's say that I want to make the number 17. How do I do that? Well, 17, it's almost 16, so I put in 16 first. So I need a 1 in there. And 16 plus 1 makes 17, so if I put another ball in here, then that will be another 1 ball in here. So, and let's just get the correct answer, so that will be 17. And if we look at this, it's essentially saying 1 times 16 plus 1 times 1, so that's the 1's column and the 16's column, is 17. And because it's binary, we don't need to think we only ever can have 1 in there, so it's really just saying 16 plus 1 is 17. So now we're going to look at doing the number 73. So first of all, how many times does 64 go into 73? Well, we can get 1 into that, so we'll put 1 in the 64. We can't get 128 in, so we won't use these ones. So we're going to have nothing inside there. Inside the 32's column, well, if we take 73 and we take away the 64 from it, we're going to get 9. So we don't need any 32's, we don't need any 16's, but we do need an 8. 8 does go into 9. So we'll take an 8. And so now we've got 9 minus 8, which is 1. So we won't need any 4's, we won't need any 2's, and we will need that final 1. 1 minus 1 is 0, and so we're done. So if we just look at what we're doing and double check, so we started off with 73 in base 10, and we've got the number which is 1001,001, which is in base 2. And so let's just double check. We've got 164, we've got 18, and we've got 11. So 64 plus 8 is 72, plus 1, which is 73 in base 10, which is the answer which we wanted to get. And so you can see there that we can convert between binary and denary numbers and back again, and it's actually a very, very simple process.